All right, let's look at the expected value, variance, standard deviation, and the median from a probability density function. All right, so expected value mu can be found. It's very similar to the one with the discrete random variable. This time, x is not discrete, so what you need to do is instead of adding them up, we're going to take the integral, right? But what you do is you just need to multiply x by its corresponding probability density. So x times f of x. Then you just have to integrate it from A to B, right? So this is going to give you the expected value mu from the this probability density function f. All right, and the variance is very, very similar. So once you found expected value, you look at the square difference between the x value and the expected value mu. Then you square that. You multiply by its corresponding probability density. Then you just have to integrate. Right? So this is the definition of the variance. And in order to find a standard deviation, all you have to do is take the square root of the variance. Right? And there's something called the median. Median is similar to expected value or mu, but it's different. Median m is the value such that if you integrate the probability density function from a to m, you get 0.5, so basically 50% chance, right? So that number is called the median. All right, so let's try to find all those values for a very, very simple example, uniform probability density function here. All right, so let's find a mu first. So if you want to find a mu, all you have to do is, x times probability density, in this case 1 over b minus a, and integrate it from a to b dx, right? So this is going to be equal to, right? So since this is just going to be a number, I'm going to kick this guy out. So you're going to get 1 over b minus a. Then antiderivative of x is just x squared over 2. Then you're going from a to b, right? And then this is going to give you 1 over b minus a. And if you plug in b, so you get b squared. Let's see, I'm going to put the 2 on the bottom here. All right, so you're going to have a b squared over 2 minus a squared. All right, luckily, we can factor out the b squared minus a squared as b minus a times quantity b plus a, right? So we can cancel b minus a on the bottom and b minus a on top, and what's left is simply b plus a over 2, right? So that's the expected value or mean from this uniform probability density function. All right, so I'm going to just box it in. All right. How about the variance? So if you're looking for variance, so sigma squared. So we need to integrate from a to b, right? Then we have x minus, right, mu value is right there. So let's see, should I put that in there? I'll actually leave mu as mu for now. Then at the end, I'm going to put it in so that I don't have to write as much. All right, then you have 1 over b minus a with respect to x. All right, so if you let's see, so we have a constant here. So as always, we're gonna kick this guy out. So we're gonna have 1 over b minus a sitting outside. All right, antiderivative of x minus mu squared with respect to x would be x minus mu cubed over 3, right? And then you're going from A to B, right? So this is going to be equal to 1 over B minus A. All right, I'm going to put 1/3 outside, so I'm going to kick this guy outside. So I'm going to just put 3 right here, right? Then we plug in b, so you have b minus mu cubed minus a minus mu cubed. All right. So let's start putting stuff in. So I'm going to actually try to go here so that we have more room. I have a 1 over 3 b minus a. Right? So the mu that we found was, let's see, you have b plus a over 2. So we can put that in there. So you have a b minus b plus a over 2. Right? And then you have to cube that. And then minus. Alright, so you have a minus b plus a over 2 cubed. Right? It looks really messy, but here we have 1 over 3 times quantity b minus a. Alright, so if you look at this, you're going to have, let's see, I'm going to put, let's see, so you have b is 2b over 2, so it's going to be b minus a 2 cubed, right, minus, right? So here, you're going to get, let's see, a minus b over 2 cubed, right? All right, let's pay attention. You have these two terms, right? They're only different by a sign, right? So the magnitude is exactly the same. So if you cube that, it's still going to be the same size and magnitude with different sign. So you are subtracting the the negative of the original one. So actually they're exactly the same thing as you have two of these guys. That makes sense? Because you have a minus negative of the original value, right? So you you have two of these added together. So knowing that, we have 1 over 3 times quantity b minus a. So you have two of these, so I'm going to put 2. And then you have a minus b cubed over 2 cubed. Right, then we can cancel quantity b minus a on the bottom. You have a b minus a on top. There are 3 of them, so we have to reduce it to 2. And one of the 2 cancel out, so you're going to have 2 here. So this comes out to be, let's see, you have a b minus a squared on top, and over 2 squared times 3, so over 12. Right, so this is the variance, and if you want the standard deviation, you just have to take the square root of that. Right. How about the median? Right, so let's try to find that. So maybe I'm gonna go over here since there's a room here. So we don't know the m is, but we're going from a to m, and then the density is 1 over b minus a with respect to x. Then we just have to set that equal to 0.5. So if you, let's compute this first. So this is going to be 1 over b minus a is just a constant. Antiderivative of 1 is x. You're going from a to m. So what you get is going to be plugging m minus plugging a over b minus a. So we need that to be 0.5, or maybe I'll do 1/2. How about that? All right? Then all we have to do is this. We can just solve for m, right? So I'm going to multiply by quantity b minus a. So m minus a is equal to b minus a over 2. Then we can simply add a. So the median m is equal to b minus a over 2 plus a. But if you take the common denominator, so a is 2a over 2, so add that, so you have a b plus a over 2, which happen to be the same as the mu, but that's not always the case. This is just happens for uniform probability density function. All right, that's it. I hope that this was clear.